Have you ever wondered what it would be like to harness the power of the quantum realm right in your own home? Imagine solving complex problems in seconds that would take traditional computers years to crack. But is it really possible to build your own quantum computer? Building your own quantum computer. Is it possible? Quantum computers harness the principles of quantum mechanics to perform calculations exponentially faster than classical computers for certain types of problems. They use quantum bits, or qubits, which can exist in multiple states simultaneously, allowing for parallel processing on a massive scale. Building a quantum computer is an enormous challenge. These machines require extremely precise control over quantum systems, which are inherently fragile and susceptible to environmental interference. Maintaining quantum coherence demands ultra-low temperatures near absolute zero, typically achieved using complex and expensive cooling systems. Currently, quantum computers are primarily developed by large tech companies, research institutions, and governments with substantial resources. These systems often fill entire rooms and cost millions of dollars. The most advanced quantum computers today have around 100 qubits, far from the thousands or millions needed for practical applications. So, is it possible for an individual to build a quantum computer at home? In the strictest sense, probably not. The technical requirements and costs are simply too high for most individuals. However, there are ways to engage with quantum computing on a smaller scale. Some companies offer quantum computing kits for educational purposes. These typically simulate quantum effects using classical hardware, allowing users to learn about quantum algorithms and principles. While not true quantum computers, they provide valuable insights into the field. Additionally, cloud-based quantum computing services are becoming more accessible. Companies like IBM, Google, and Amazon offer platforms where users can run quantum algorithms on real quantum hardware remotely. This allows individuals to experiment with quantum computing without the need to build their own hardware. For the truly ambitious, there are ongoing efforts to develop more accessible quantum computing technologies. For example, some researchers are exploring room temperature quantum computing using diamond defects or photonic systems. While still in early stages, these could potentially lead to more manageable quantum devices in the future. Looking ahead, as quantum technology advances, we may see the development of smaller, more affordable quantum processors. Just as classical computers evolved from room-sized machines to handheld devices, quantum computers might follow a similar path. However, this process will likely take decades and require significant technological breakthroughs. In summary, while building a full-scale quantum computer at home is currently not feasible for individuals, there are ways to engage with quantum computing on a smaller scale. Educational kits and cloud-based quantum computing services offer opportunities to learn about and experiment with quantum algorithms without the need for expensive hardware. Ongoing research into room temperature quantum computing and more accessible technologies may lead to smaller, more manageable quantum devices in the future. While personal quantum computers may be years away, the field is becoming increasingly accessible, opening up new possibilities for individuals to explore this cutting-edge technology. Thank you for watching our exploration of quantum computing and its potential for personal use. We hope this video has sparked your curiosity about the fascinating world of quantum technology. Remember, while building a full quantum computer at home might not be possible yet, there are many ways to engage with and learn about this groundbreaking field. Keep exploring, and who knows, you might be part of the next big breakthrough in quantum computing.